Welcome to Spring LIB.
So let's see how quantities momentum and kinetic energy depends on the mass and velocity. So momentum is a vector quantity that depends on that is proportional to the velocity vector of the object. And kinetic energy is a scalar quantity that is proportional to square of the velocity. Therefore, because one of them is vector and the other is scalar, our case will vary from a single object to multiple objects. So for a single object, if momentum is zero, this means that velocity of that object, of that single object, is zero. Therefore, the magnitude of velocity is also equal to zero because we are talking about a single object. And this means that kinetic energy is also equal to zero. Now, when you talk about more than a single object, so when you have two or more objects, and each of them has a specific velocity, in that case, momentum vector will be equal to m1 v1 m2 v2 vector addition of the individual momentums of all objects. This means that if momentum vector is zero, this means that v1 vector, if considering the masses are all equal, so I am solving this for a simple case, but this will be also applicable to multiple masses. So let's say that masses of all the objects are equal. So the zero momentum will mean that vector sum of all the velocities of the object is zero. Now, when you talk about a vector addition being equal to zero, consider a circle or a vector like this. So, this is v1, v2, v3, v4. And a circle can be also thought of a vector addition of a number of small vectors. So basically, for a circle, when you talk about velocity, you are speaking about the tangential velocity and the magnitude of tangential velocity because the direction of that velocity keeps on changing. It is always tangential to the path of the circle, and therefore the direction keeps on changing, but the magnitude of the velocity stays the same. Similarly, for this case also, even if your each of these vectors are not zero, they have some value. The vector addition of these vectors becomes zero because if you are starting from a single point, the vector addition results in uh, being back to that point. Therefore, the vector sum becomes equal to zero. However, this doesn't mean that the kinetic energy will be equal to zero because kinetic energy will just be equal to kinetic energy of the individual uh, objects. And when you plug in the velocity, you're just substituting the magnitude of each of the velocities of the object. Therefore, even though the vector sum of the velocities is zero, that result in a zero momentum, the kinetic energy for the same objects won't be equal to zero. Thank you.